Hi guys, welcome to Algebra 2, section 4.7. We're going to talk about completing the square today. A couple different uses of completing the square, but let's just review real quick methods of solving. So there's a lot of different ways. We've talked about factoring and square roots already. Today is the completing the square method, and there's a couple other methods, but the idea is each of these is a way to solve problems. So one of many. So first of all, what is completing the square? Well, really, it's a geometry idea. It's geometric. And so there's this quotation here as defined as the process of adding a term. When you see an expression like this, x squared plus 4x plus 2, oftentimes that last number there isn't what you want. It isn't a completed perfect square. So you notice in this picture here, what we really are looking for is how many yellow squares would be needed to make a perfect square. Well, in this case, we're missing 2. We need 2 extra yellow squares for a total of 4. So a total of 4 extra squares or 2 extras would complete it. So in this case, if we added 2 to here, so like this blue is the x squared, each of these green things, the area would be x. And then what we're missing here is we would really want plus 4. And that term right there is oftentimes the one we'll change to make a perfect completed square. So if those are filled in, this figure here would be a perfect square. So what we do is we kind of look here and say, all right, we just did this problem where it would be, all right, with this one right here. And when we go back to it and look, what would the length and width of this be? So that would be like x plus 2, if that makes any sense. And on the other side, you have the similar x plus 2. So when you advance here, this would be our problem, x plus 2. Well, you can go through and do this similar idea with different ones. So like here's this first example, x squared plus 2x plus. How many yellow squares would you need to fill in this particular region? Well, in this case, just 1. What would the length and width be? Well, it would be x plus 1. So that's the idea there. When you look at this picture here, well, now this is the one we just did. So we have, let's see, x plus 1. You need, let's see, what is this? 1, 2, 3. You need 4 yellow squares to fill this in. So that's that example that we did. We try a new one here. Oh, okay. So now we got some more space. And so now we have to figure out how many yellow spaces we need to fit in here. Well, let's see, how many would fit? It looks like there would be 9 of these. And so that would be a sort of x plus 1, 2, 3, so x plus 3. The question here is, okay, if you didn't know what b was, how could you find it? Well, there's a rule that says, hey, you just take these terms here, cut them in half, and square them. So b over 2 squared. That's kind of your rule here. And then this would just be b over 2. So as we kind of go through, it just comes from a pattern. These are your rules. So the way to find the value of c is with this rule, and then you can find the whole completed square with the new value of c and factored there. The other idea, the purpose of completing the square is so you can factor. We'll do that in just a minute here. That's a really big note there on the bottom. All right, let's do some problems. So here's the problem. Well, the idea is that is not the number that you want. So what we want is we want the value of c equals 25. How do you get that? Well, you just use our rule. The rule says b over 2, and then we're going to square it. So in this case, b is negative 10. We're going to take that and divide it by 2, and we're going to square that number. And that's where we come up with the 25. So, all right, we have 8. We want it to be 25. So that's where we add 17. That's what that idea is. Add 17 to both sides. All right, now we have a completed perfect square. The purpose of doing this, the purpose of completing the square is so we can factor. So this left side will factor down into x minus 5 squared. Now it's kind of a normal problem. Now it's something that you've done frequently, where you take the square root of both sides, drop the bars, add plus or minus, add 5 over to solve for x, and there's your problem. It's problem's over. So we just completed the square to get from here to here, and then it's a problem that you already knew. All right, let's take a look at a different kind of one. So when you look at a different kind of one here, this one's different because the a value is greater than 1. In this case, a is 2. We're going to start this problem off by dividing through by 2. That causes us a little bit of problems because now when we go through our problem, we'll just kind of show you the steps. You want the c value in this case to be 25. We have to add 33/4 to each side. And that can be kind of confusing at first, but you kind of think, hey, we're at negative 2 right now. This is at -2. We don't want it to be -2. We want it to be 25 fourths. Well, how do we get there? That's where we get that 33 fourths added to each side. All right, the square is complete. So now we will go ahead and factor each side. Actually, this the left side. So we've got this b over 2, 5 over 2 in there. And then we're going to continue. We're going to take the square root of each side. So we've got that. Notice that this 33 fourths changed to square root of 33 over 2, because when we took the square root of this whole thing, the square root of 4 was actually 2, the square root of 33 remains. Drop the bars, add plus or minus, and continue this process to solve for x. There we go. So this one's kind of challenging, but you know, it's the way it is sometimes. You have to deal with fractions. Another use of completing the square is to change forms. So first things first, you don't want this to be a 2, so we'll go ahead through and divide by 2. When you divide by 2, you're dividing everything by 2, every single thing. So you get something like this. Okay, and then we want to complete the square. So this 2 is not the number that we want. So we want to change that. We want that c to actually be 9. So how do we get from 2 up to 9? Well, that's why it says add 7. Add 7 to both sides. All right. The purpose of completing the square is to factor. Factor the right. Okay, and so we'll go through and we'll do that. We'll say, all right, factor the right side. And then we'll subtract 7, multiply by 2, and there's our final form. This is vertex form. The nice thing about this is you can tell the vertex very easily. X is -3, Y is -14, and you're good to go. These are the things you should be able to do. Thanks for joining me in completing the square problems.